Now let's understand the instantaneous velocity. So we're talking about the velocity that it was the disposition or displacement divided by changes in the time. But the instantaneous velocity is the velocity of an object that at instant in a time. For example, we mentioned to the example of an iguana that moves like in a freeway 50 miles per hour, but like for 2 minutes is going 80 miles per hour, and the cop just pulled over the iguanodon and asked him why he was going the 80 miles per hour, and when he calculates the velocity, he says, okay, so my velocity was 55 miles per hour. But when we talk about the instantaneous velocity, we're talking about the velocity of an object in that instant time. So for example, we have a velocity as limits. We have the changes in the time approaches to the zero. So we have this placement divided by changes in the time. So we have the dx over dt. So that's the first derivative. The instantaneous velocity is the slope of the tangent line to the position function. So if we have the secant the other side, so that is the tangent line. So instantaneous velocity is the slope of the tangent line. So that's also the important that we realize it's not the slope of the secant line, but it's the tangent line. The example we have is the ball. A ball falls to the ground with a non-uniform average velocity as it shows by parabolic position function. The shallow slope of the lower secant indicates that the ball falls slowly during the first half of the time interval, the yellow line. Okay, so slope is the average velocity of the first half of the ball of the fall, and the step slope on the upper secant indicates that the ball falls more quickly during the second half, and that is true. So to determine the speed of the ball at this specific point in time rather than over an interval, you need to calculate the instantaneous velocity instead of average velocity. So what's the speed of the ball at the t1? What's the speed of the ball at the t2? So we have to calculate the instantaneous velocity rather than calculating the average velocity. So the longest secant represents the average velocity of the ball over a 3-second interval. The slope of the shorter secant line represents the average velocity of the ball over a time interval of the 2 seconds and 1 second. The line shown on the right side of the image represents the velocity of the ball at the t equal 1 second as the time interval approaches zero. It is the instantaneous velocity, so velocity limit as approaches zero. The instantaneous velocity has the same slope as the tangent to the position curve at the t equal 1 second. The curve on the left represent the complicated position function of an object. So it goes up, it stops, goes back. So this is very complicated. This is a much complicated. And at the t1, the slope of the tangent is steep and positive, so instantaneous velocity is large and positive. At the t2, so the slope of the tangent and instantaneous velocity are zero, so the object is not moving. At the t3, the slope of the tangent and instantaneous velocity are negative. The object moves in the negative direction, positive, zero, and the negative. So this was all about the instantaneous velocity, and I hope you enjoy it.